Hello friends, it is a database management system assignment 6 of an NPTEL course in the year 2019. I am going to explain all the questions in a detailed way. Please concentrate and get maximum benefit out of it. Coming to question number 1. Consider a B plus tree in which maximum number of keys, it is given maximum number of keys in a node is 5. What is the minimum number of childrens in a non-leaf node? Number of childrens nothing but number of pointers. Number of pointers in any non-leaf node, non-root node other than root node. Actually minimum order is an exception for the root node, that's why it is clearly given non-root node. Now what is given? Maximum number of keys given. That maximum number of keys equal to 5, which is equals to n minus 1. What is n? N is called order. That order will specify in a non-leaf node number of pointers. If maximum number of keys equal to 5, then maximum number of pointers, how many? Maximum number of pointers will be n. So means if 5 equal to n minus 1 means n equal to 6. Then the minimum number of pointers is always be half. Why? Because the minimum fill factor of B tree and B plus tree is 50%. So that minimum number of pointers is n by 2. That is 6 by 2, which is equals to 3 pointers. 3 pointers. What is the question? The minimum number of childrens, nothing but pointers. How many pointers are possible? 3. So answer for the question 1 is option B. Question number 2. A hash table of length 8 uses open addressing with hash function h of x equal to x mod 6. h of x equal to x mod 6 and a linear probing. What will be the content of the table after inserting the 6 key values? Here it is mentioned the 6 key values in the table. It is mentioned open addressing with linear probing. In open hashing, set of buckets is fixed. So the number of buckets is fixed. Because number of buckets are fixed, there will be no overflow chains. That point you keep in mind. This may be useful for other questions also. With open addressing with linear probing. What does it mean, linear probing? The linear probing says if a bucket is full, the system inserts record in the next free bucket. Means not according to the hash function. Suppose hash function x mod 6 gives you some 1. Suppose if one bucket is already full, it will search for the next available bucket. So that in the next available bucket, it is going to store the record. Now look, what are the key values given? 26, 2, we have 22, then 37, then 19, then 45 and 29. For all of them, we have to see what is mod 6. 26 modulus 6, that is 2. It means this 26 should go into the bucket number 2. Look in the options. 26 is there in the bucket 2 in all of the options. So that we cannot eliminate any options. Next, 22 mod 6. This 26 already there in all of the buckets. Next, 22 mod 6. 22 mod 6, which is equals to 4. So that 22 should be there in the 4th bucket. Here also 22 is there in 4th bucket in option A, B, C, D. All. So all are correct. Now 37 mod 6. 37 mod 6 equal to 1. So it expecting that 37 in the bucket 1. It is correct. It is correct. It is correct. It is also correct. Now 19 mod 6. 19 mod 6. 19 mod 6 equal to 1. So means it should go to bucket 1, but bucket 1 is already filled with 37. Then what system do? The system inserts this 19 into the next free bucket. What is the next free bucket? Now next free bucket is, now 2 is already occupied. Next free bucket is 3. Now 19 is to be inserted in bucket 3. But here 19 is inserted in fifth bucket, but 3 is free, it is not used. So option B is incorrect. And 19 is inserted in third bucket, next free bucket, it is correct. And 19 is inserted in the sixth bucket by ignoring the free buckets 3 and 5. So option D is incorrect. Next we continue with 45. 45 mod 6, which is equal to 3. So means this 45 should go into the third bucket. Look, third bucket is already filled. Because it is already filled, it should be inserted into the next free bucket. What is the next free bucket? Fifth bucket. It is correct. But here you look, 45 is inserted in the sixth bucket by ignoring the fifth free bucket. So option C is incorrect. So what is the correct answer? Option A. And lastly 29 mod 6, which is equals to 5. Now fifth bucket is occupied, so that it will be inserted in the next free bucket, that is 6. So answer for the question number 2 is option A. Question number 3. Consider the following query. The query given is, select SSID count star from student group by SID. Now what is the correct property of the index? If an index on SID is available, and the query can be answered by scanning only the index. Now what we conclude is, as per the query, we need SID and count. We need SID and count in the student table. So using only index file, we can get the result regardless of the type of the index. So both hash index and b+3 index can return the results. Fine. So that we cannot say only hash, only b+3. So either hash or b+3 is suitable for returning the results. So answer for the question number 3 is option C. Question number 4. There are 5 records in a database. Here 1, 2, 3, 4, 5 records are there. Okay, there are 5 records in the database, with some values are given for the attributes name, age, job, salary. There is an index file associated with this table and it contains the values 1, 4, 2, 3, 5. From which attribute is the index built? We check for option A, age. If I am taking age, the first index is given to the first record, 25. But observe friends, less than 25, 21 is there. So because less than 25, 21 is there, index is ordered, the first index will be given to 21. But first index is given to 25, which is incorrect. Look for option B, job. Because job contains alphabets, means strings are there. Strings are sorted in the alphabetical order. And in the first letters of job, A, E, C, D, M are used. Now in the order, A will come first. A will be given index 1. Okay, first index is correct. And next index is B, C. C is a third record, will be given index 2. Here look, third record is given index 2, correct. D will be given the third index. Doctor is given third index. So fourth record is given third index. Then E will be the index number 4. That is second record with index number 4. And last is fifth. So manager. So that this order is correctly matching with the attribute job. So answer for the question is job, and remaining all are false. Question number 5. Consider the employee table having attributes ID, name, occupation. Given, consider the bitmap index for the occupation field. Bitmap index is there with this field with F1, F2, F3 and F4 representing the different occupations. If the bitmap index value of F1, F2, F3 are as follows, these are the bitmap indexes are given for F1, F2, F3, Identify the correct option representing F1, F2, F3. As we know that bitmap indices are a special type of index designed for efficient querying on multiple cases. In a bitmap for value v, the bit for a record is 1 if the record has the value v. If the record has a value v, bit is 1 for that attribute and is 0 otherwise. Now look, first one F1, it is 0 0 0 0 0 0, then 1. So means observe here, after 6 records, 7th record is given 1. Now in the occupation field, just observe, this is the first, second, third, fourth, fifth, sixth and 7th record is 1. Now this is 1 for the value analyst. It means the F1 is built for the value analyst. So because it is analyst, now next 3 values are zeros. So next 3 values are zeros. It is zeros because the value is not analyst. And the next value is 1. Why? Because it is analyst again. The next is clerk. Clerk means it is 0. Fine. So means that F1 is representing the analyst. And what is F2? First value is 0. Second, third is 1. What is second and third in the table? That is salesman. It means that F2 is representing salesman. And F3 is first record is 1. What is the first record? It is clerk. Okay, it is clerk. So means that F3 is for value clerk. Now what is a correct combination? Analyst, salesman, clerk. That is option A given. Clerk, salesman and manager incorrect. Salesman, analyst, clerk incorrect. Analyst, salesman, it is correct. But third is not manager, third is clerk. So the correct answer for the question is option D. D is the correct answer for the question. Question number 6. Suppose that one block in a disk can store either 5 records or 15 key pointers. If a database contains 1000 records, how many blocks do we need to store the data file and the dense index? Now what it says, one block in a disk can store either 5 records or 15 key pointers. That average number of records in a block, we call it is a blocking factor. Here the blocking factor is either 5 records. Records are stored into the data file. So means this 5 records is for the data file, are 15 key pointers, 15 key plus pointers. Key plus pointers are used for the index file. Now question is, suppose that one block in a disk can store 5 records or 15 key pointers. If a database contains how many records? The number of records are 1000 records. How many blocks do we need to store a data file? And the dense index. What is dense? Dense requires to have index for every key, because index is required for every key. So the number of records in the dense index is same as number of records in the data file, that is 1000. This point to be noted. So that we need to find number of blocks in the data file. Number of blocks are equals to 1000 by 5, which is equals to 200 blocks in the data file. Blocks for data file. And next we need to find blocks for index file, because we are creating dense index. In the dense index, number of index records are equals to number of records. Because we have 1000 records, we have to create 1000 index records. In each block it is able to store how many records? 15 records. When I find 1000 by 15, it is equals to 66 point something. We have to take 67 upper bound. Why? Because 66 is okay, but point something we have to store into the next block. So that always we have to take upper bound. So the question is the total number of blocks. How many total blocks are required? 200 plus 67, which is equals to 267. That is an option D. So answer for question number 6 is option D. Question number 7. Which is the correct 2, 3, 4 tree with the following keys? Keys are given. Now what is 2, 3, 4 tree? Every node is a 2 node, 3 node or 4 node and holds 1, 2 or 3 data elements respectively. And keep in mind, the question is about insertion. When you are inserting, if an overflow is possible, first it has to split. This point you keep in mind. Then we have to insert. But actually in the B tree and B plus tree, first we are inserting, then we are performing a split. But in 2, 3, 4 trees, first we have to split, then we have to insert it. Now look, this is a node. First we inserted 11, then 33 and then 44. Now these three key values are possible to be inserted. Now after inserting these 3 key values, it is a 4 node tree. It is a 4 node tree means it is having 3 data elements and 4 pointers So means it is a node that is completely filled. Now it is to be insert 22, but because it is already 4 node, now inserting 22 is not possible. What we have to do, first perform a split, then perform insert. So how to split? Middle key 33 should move up, left of 33 should be 11, right of 33 should be 44, then 22 to be inserted in the correct position. So when 33 moves up, now new root is called 33, its left is 11 and its right is 44. Now after splitting, it has to be inserting 22. Now 22 is inserted. Next we have to insert 77. 77 should come after 44. Next 66. Now 66 is between 44 and 77. Now it become a 4 node. If it is 4 node, means 3 data elements and 4 links we have. Next we have to insert 99. But inserting 99 is possible in the node 44, 66, 77. But inserting 99 is not possible. So first we have to split, then we have to insert. Now split requires this middle element 66 should move up, left of 66 44, right of 66 77, then you insert 99. So when 66 move up, now this node becomes 33, 66, left of 33, now it is 11, 12, the middle one is 44 and right of 66, now it is 77, after split completed, now insert that key 99. Now key 99 inserted. Next we have to insert 55. 55 is greater than 33, less than 66, so that 55 will be inserted in the middle node. After inserting 55, next we have to insert 88. Where 88 is to be inserted? Between 77, 99. Here 88 is to be inserted. After inserting 88, next we have to insert 90. But where 90 is to be inserted? 90 is to be inserted in this node. But this node is already 4 node because it is having 3 data and 4 links. First it requires to perform a split. Means this 88 middle should go up. Left will be 77, right will be 99. When 88 moves up, now the node becomes 33, 66, 88. Left of 33, now 11, 12. Middle one, it will be 44, 55. And 66 right or 88 left is 77. 88 right is 99. Now split is completed. Next we have to insert this 90. Where we have to insert? Here. So that this will be the resultant tree. Now check the options. Which tree is matching with the insertion that we have done? Now look for option A, 3377. Here it is incorrect. Option B, you look 33 66 88, correct. 11 12, it is correct. 44 55, correct. 77, correct. 90 99, correct. So answer for question number 7 is option B. B is the correct answer for question number 7. Question number 8. What is the maximum possible height of any balanced binary search tree with 7 nodes? So it is a direct formula that the maximum height of balanced binary search tree h equaled log n base 2, where n indicates number of nodes. So it is log 7 base 2. This should be upper bound. Log 7 base 2 is 2 point something. So that this will be equals to 3. So the maximum height of balanced binary search tree is 3. That is option B. Question number 9. Which of the following is dense index? Now what is a dense index? Dense index need to have index record. It required to have index record for every search key value. For every search key value, if we have index, then it is called dense index. Now look, primary index is not dense. Instead it is called sparse. Why? Because primary index entry is created only for some key values. It is same for even clustered index. We call sparse index. And in the secondary index, we create index for every key value. So that secondary index is called dense index. And we know sparse. What is a sparse? Index entry is there for some key values. Because index is there for some key values, we call sparse. So that what is the correct answer for the question? Option C. Coming to question number 10. If a table has an index table like the following. Now this is a table is given and its index table is given. Now select the correct option for the above index. There are various options are given: primary, secondary, clustering, non-clustering. We should understand. Here index is created for 101, then 102. You just observe above 102 this record. This is all 101 records. Next index record is 103. When you observe the records above 103, all are 102 records. Next 103 record. Next 105 records. So what does it mean? Now look, this is a cluster. This is a cluster of student IDs 101. This is a cluster of student IDs 102. This is a cluster of student ID 103. This is a cluster of student ID 105. So it means it is creating index entry for each cluster. If index entry is created for each cluster, such an index is called clustering index. So answer for the question number 10 is option C. Thanks for watching. Please like, share and subscribe.